Okay, so we can start with this the last session. It says smart technologies. We know that quite a few operators now, they invest. Deutsche Telekom, OTE also has invested. We do have some pilots of what we call smart cities, especially where we do some smart parking, smart lighting. We started with those two. But we think to increase that also for tourism and some other fields. So in this session we have two talks. The first one is going to be given by Jonathan, if I say it correct now, Spruytte, something like this. Okay, he's coming from University of Gent, and he's going to talk about a theoretical approach for a multi-operator synergistic utility planning and its real-life implications.
So, hi, I'm Jonathan. I will be talking about a multi-operator approach to utility planning. It's about smart cities, but not really about the technologies of smart cities, more like the approach to install the technologies for the smart city. We all know this. We have so many boards up saying that there are traffic jams, that there are traffic works, and I don't know about you, but I hate it. I come from Belgium, and we see these signs everywhere. There are so many traffic jams, and it's just, sorry for my language, it sucks. So what we want to do is we want to improve this planning. If I just take some figures from Ghent, from the city of Ghent, in the next couple of years there are almost 400 utility works planned. 400. That's quite a number. From these 400, 80% can be executed in synergy. This means that there's some kind of overlap. This means they are in the same area, they're very close to each other, or so on. But this is the sad part. Only 28% actually are executed in synergy. That's not nearly good enough. So what do we have? We have very low synergy levels within the planning, and that leads to very high economic costs. As Ralph said earlier today, the digging costs, the labor costs are very high in utility rollouts. But also there's more about it. There are also indirect costs, such as damaging infrastructure that's already in the ground. And also, as I said, there are a lot of traffic jams. These lead to additional economic losses and so on. So just not having a good planning for your cities just sucks. So what do we want to do? We want to improve this. So the 28%, we want to increase it to as much as we can. So what we're going to do is we're going to adjust the existing planning of all of these utility operators. And how are we going to do this? We're going to see which construction zones are close to each other, and we're going to reschedule them so they match better. Of course, we have to keep some things in mind. For example, you will not reschedule urgent maintenance. If there's going to be maintenance on the road that needs to happen for like the next month, you're not going to do it in 2 years. That makes sense. Additionally, you cannot do all your works in just a single year. That would be great. Just open up every street, just install everything anew. But of course, that's not logical, not budget-wise, not practically. Just you're not going to do that. And also, there's a big difference about small and large players. In Belgium, we have a lot of very small utility operators that only work in a small region and just a single city, while others actually govern the entire country. So these plannings of a very big company might be difficult to reschedule, but for the small ones, okay, they might not have a lot of budget. So there are very difficult things at stake. And that's not too much. And then which data do we have? Well, actually not a lot. We're going to start from the existing plannings of the utility operators. So we have a location, we have a date when they start and when they should end, and a type and a status. A type is what kind of work it is, and status is, as I said, is it urgent or not. And what we used also is the street plans, because we want to project them, as in geographically we want to symbolize them in a uniform way. So just from these two data sets, what can we do? The first one is as easy as it is. We can detect whether two works are overlapping physically. There's not a lot of crazy stuff going on. That makes sense. You can, if you're going to dig twice in the same area, okay, if you do it together, you pay the price only once, so you have cheaper costs, of lower costs. The other one is the street segments. So if you're going to work closely together, okay, there are no real economic benefits at first sight, but if you actually think about it, you are not going to close the same street twice. You can optimize your traffic divergence and so on. So there is something there. We cannot really quantify it at first hand, but we know there is something there. And as I said, we cannot quantify everything just the way we want it. Because, okay, working together will lead to some economic benefits, we all know that. But how much exactly is simply no way of telling. First of all, if a water company and a gas company are working together, that might be a different benefit than if the electricity company and the gas company are working together. That really saying how much each company will benefit from each type is very hard thing to do. So we threw away everything that's money and we invented a point-based system. A point-based system which actually means if you're working together, hooray, you get good points. If you're not working together, or if your new planning is like totally different than the old one and your budget is not being restricted or not being respected, then you get penalties. That's easy enough. So this is what we came up with. We have one big score and then we have a couple of categories. The first one being a score per utility operator and the other one being the synergy score. The left-hand side is actually just one operator at a time, while the right-hand side is actually the cooperation, so multiple operators at the same time. So the first one is actually, we're going to calculate some points, some fitness per actor, and we have not a lot of information about this. So what we're going to do is just compare per work the original planning and the newly planning. Okay, as I said, we have urgent works that should not be replanned or rescheduled, and on the other hand side, we have also maybe like a structural rollout for the next 3, 4, 5 years. It will or it has to happen sometime, but when exactly we do not care. All we know is it has to be new cables on the ground. So we have a time and we have different time forks actually. What we can do is, for example, if you have a work that is presented in red, we're going to define a time fork around it which says, okay, you can easily, without any penalty, reschedule this work so many weeks or months or years in advance or later on. These time forks can be asymmetric, meaning that, for example, yeah, you cannot reschedule it earlier, but we do not care about later. That might be a reason for like structural rollouts. The cables has to get in the ground. But for example, for the maintenance, okay, it cannot be, in any case, be planned later. Earlier is okay, but not later. So what we've done is, for this we calculated the most basic penalty cost you can think of, being the number of weeks that you plan it too early, and you multiply it, and so on and so on. But that's just a way of giving it a penalty score if you're not respecting the planning. Additionally, and about the same approach, we also do the yearly budgeting, but I was told I was only having like 12 to 15 minutes, so I kind of omitted this. Too bad, but it's in the paper, so read the paper and every details are in it. So coming back to this, as I said, we have the left-hand side that works about the utility, the score per utility operator. The right-hand side is actually synergy. It's actually working together. We're going to create bonus points for when you are working together. And as I said, we have two ways of overlapping, 2 ways of actually working together. The first one is physical, the second one is the street segments. The physical is actually working in the same place, street segments are just working close together, the same crossroads, the same streets, just a bit of everything. So again, the way that we're calculating the synergy scores could not be easier. We're taking the area of each work and we see what percentage of overlap is in place. Here I'm talking about area. Sometimes the length of a work might be more applicable. It depends on type to type. For example, if you're working with street, okay, then you really have a big area of like 2, 3, 4 meters that is being worked in, well, in width. But while for example, installing new electricity cables, yeah, you're working on the footpath, so that's really small. I don't know, about a meter. So maybe just taking the length may make more sense. That's something that you should think of, and simply decide which way works better. So what we've done is we calculated the physical overlap. We scored it between 0 and 1, and we look at the time. What we do here is actually calculating an overlap in time, so we're doing exactly the same. If you're representing, like here, 2 works in red and blue, you can simply see how much of the weeks are overlapping, and we just score it again. Afterwards, we just multiply it, and we have a score where if 2 works overlap physically very well and very well in time, then the score will be high. If one of them is low, okay, the score will be lower. It could not be easier. So, as I said, these can be configured per actor and per type. So, for example, imagine if I'm an electricity company and I'm saying, okay, this maintenance, I don't need someone to cooperate, I just want it planned and I don't care about everything else. Okay, then you just say this parameter is 0. I do not want to score anything on it. But for example, for the very big work, you say, okay, this is really important, it's going to cost me so much. Let's just give it a very well score, a high parameter, so you really want to cooperate on this very specific type of work. So these kind of parameters, these exponents, actually allows us to reflect the reality as good as possible. And the last one, I talked about the physical overlap. The street segment is, again, the same idea. We're going to look at how well does it match in the street, closer or further apart, and again, we look at the time. But again, that has been omitted in the presentation because I thought I had last time today. So we come back to this, and we've seen everything except for the extension possibilities. It's a model. So if, for example, you think that there's additional parameters that should be in place, for example, think of a number of kilometers of divergence that is in your city at the moment. For example, if you just think about shortest paths and you calculate for every hot spot in the city, and you simply see how much additional diversion you need to get from A to B. That might be an additional value that you could include, and the lower it is, the better. So it's just a model, and it can take a lot of parameters, so it's sky is limit. If you think something else should be in place, you can simply configure it. So this model has been implemented. It has been implemented as a genetic algorithm. I'm not going to bore you with the details at the moment. That's not really important. This genetic algorithm simply was a prototype to show that the model actually is capable of generating a better synergetic planning. So we applied this model to 2 cases, and the first case I will introduce at the beginning. So this is Steve Gant with 80% of possible synergy gains, starting off with 28, and we managed with just a very minor prototype to improve it with 32%. That's rather good. Again, for this, we actually put the algorithm rather strict, so we could not move around so much, but already we see that there's a lot of possibility for improvement. What's even more important is that there are 46% additional weeks of cooperation. Not just more works in cooperation, but also the work that were already executed in synergy. We managed to align them and actually came up with an even better planning, so hooray for us. We have an initial case, a case that is just a bit small, also a Belgian case. We started off with better synergy, and even there again we managed to actually improve it. So hooray again, we know that our model is working. We see that it really improves the original planning. The percentages here are lower simply because we have a smaller case and less possibility of synergy gains, because the works were more diverse within the city. So I'm coming up to my last slides. We have developed a synergistic model which manages to create a synergistic model for all of our utility operators, keeping in mind that there are some restrictions as the original planning, the budgeting, and so on. And based on this model, based on our prototype, we have managed to actually improve the synergy up to 32% and even 46% more of weeks executed in synergy. So hooray. This will, without a doubt, lead to additional cost reductions. We will reduce the digging cost, and also it will benefit our city, well, these cities, because there are going to be less traffic jams, there are going to be happier people. So all in all, that's just a good thing. Thank you.
Thank you, Jonathan. So, Jonathan, I thought one time, that only Greece was the bad example. Where we have in all the regions, we have the different utility operators coming one after the other, digging, putting the cables, cover the soil, and then the other one is coming. But it happens that I go quite a few times in Brussels, and that's another bad example. That's the capital of Europe, eh? Yeah. I thought only in my capital, in Athens, we see this thing. But you see, quite a few roads closed because of works. Yeah. That lasts forever, eh? It's worse than Greece. Okay. So now we come to the last presentation by Felix Herrera from COIT. Yeah. He's going to talk about smart cities, smart regions. Very interesting.
Good afternoon. My name is Felix Herrera. I am the coordinator of the group of smart cities and smart regions from the Colegio Oficial de Ingenieros de Telecomunicación in Spain. Today we are going to talk about the last work. This is an analysis of the smart trend in Spain. So for the agenda, only 4 points. One small presentation, who we are, what we do. Next, the problem. So we are going to talk about what is the smart trend in Spain and why, especially why. The third point is the solution. It's just the analysis, our work. And finally, the conclusions. So, who we are? We are a group. We are a group of some telecommunications engineers that work in this topic. Let me say hello to 3 members here, Daniel Vega, Francisco Díaz, and Gustavo Bermejo. And we are working basically in this world of transformation from the city to the smart city. So this graphic is a good representation of our work, because we always think about to pass from the left-hand side to the right-hand side. Another topic for us, very important, is the transformation of regions, because most of cities belongs to the regions, and sometimes they have projects that cooperate, and it has very, very interesting results for us. About we have more different works and research and many different opportunities in the world to present this some different papers and documents about this topic. Part of the results today is a report that we are going to get ready probably in 1 or 2 weeks, and it will be in the College of Telecommunications for every people. Okay. About the problem, what is the smart trend in Spain? If you see the graphic here, inside the graphic you can detect the widespread model of 6 blocks to transform a city from the University of Vienna. And you have some blocks like mobility, economy, etc. The cities, when they work in the smart city plans, sometimes we have a graphic, a different graphic like the representation in the slide. So in Spain, many cities work in smart city planning, and you have different topics, different areas, different blocks in this transformation. But an important question here is not all the cities are the same. It's not the same Singapore or Madrid or Barcelona or a small village. But in the smart city world, the problem is many times You use models and you use plans to transform without this consideration. In Spain, 2 years ago, we have an important, the first national plan for transformations of smart cities with 188 million euros, and it's an important boost for many cities, many local administrations. Are the city truly smart? We think no. Absolutely no. Why? Because, you know, the times goes on, and sometimes you solve the problem. Always you think you have a problem in your city, and the solution, the smart solution you get is only for a limit people or for a limit public objective. And for us, we have another question important in this transformation. If we need really technical transformation or urban transformation. For the telecommunications engineers, it's very important to have technology. All the transformation is important for us. But you can see here the technology projects you finish the projects faster than any other urban project. This is a framework. It represents exactly the measure of the smart city. In the core, you have the problem solution. Many cities have a problem, and they try to solve the problem with 2 or 3 or 4 projects. But for us, the main or the key of the smart level of a city is the scope of the solution. Because for a city, a solution is not only for a district or for a specific area or for a pilot project inside the city. But many cities, when if they have only 1 or 2 projects, they always say, I'm smart, you know? And the third level, you have the people, the real receptor of the smart product. So for us, when you talk about a smart city, you need to complete all the levels. And today, we are only concentrated just in the core. The analysis. The analysis is based in the national plan, and we have a classification, an initial classification of 3 types of city, type 1, 2, and 3. Type 1 is all the cities that they had a plan, a smart city plan. Type 2, they expect for money, for financing, to solve the problem. And type number 3, normally are the small cities, without a strategic plan. The analysis, you can see here, we have 6 elements. Elements like the intention to change, the areas, the standardization, many standards in the world, the trend of the national plan to transform these Spanish cities, and other potential, the smart destination, the interaction of the wall of the smart destination with the smart city wall. And to see the results, you can see here, almost 77% of the proposals in Spain not advanced. For the second 4 projects in this plan, 95% don't progress. So it's not the plan is a good plan, of course, but we need in Spain more effort Here you can see the priority areas for 202 cities in Spain. Basically, you have the environment with 29%, smart living 24%, and mobility 17%. This is a distribution of these 202 cities. If you make a zoom of the last slide, you can see here with more precision the energy and transportation and traffic and public infrastructure, like the most important sub-areas inside the study. And in Spain, tourism ranks number 8. About the standardization, 2 of the items are the same like in the last slide. So it's important to see the synchronization between the standards and the main projects of the cities in Spain. About the trend of the national plan, you can see here 2 differences. Is 60% of the plans is concentrated basically in infrastructure, and the rest is concentrated in knowledge, know-how. And for the conclusions, only 5, you can see here. The cities in Spain have high interest. Many cities are excluded from the process now. We need more time because most of the projects need 2 or 3 years to finish all the topics. The scope is the key because of the circle, the level, the framework that we saw before. And the main problem in Spain probably is the high number of small cities and rural access that we have. Okay, thank you.
So do we have any questions about smart cities, smart people, I heard? Oh, Ed, yes. Where's the nice lady? Here's coming. Okay.
Thank you. My question's for Jonathan. In looking at the synergies of roadworks or your cost model for non-overlap, the experience in the UK is that some roadworks cost a lot more than others because they impact local businesses. Do you have any granularity in your model that allows for that kind of thing?
Yeah, you present.
Well, you could actually classify them based upon the location within your city. That's actually something that we looked into. For example, roadworks that are in the middle of a city should be planned more optical than the ones that are in the side of the city, let's say, because the impact of not planning the ones in the center optimally might even be worse than the other ones. So it's not included in this model, but there certainly are possibilities to do so.
That sounds interesting. Thank you.
Oh, yes, Andy.
So this is the question for Felix on smart cities. It's a very nice proposition to have a smart city, but the analysis that I've seen elsewhere says that one of the problems with smart cities is that the people, and I think you indicated this, the people behind aren't necessarily smart enough. So the problem tends to be the interaction between the various organizations. So very often you don't get the cooperation that you need, for example, you know, between the doctor's surgery and the hospitals and so forth. So the cooperation just at the organizational level can actually, the evidence I've seen, negate the sort of advantages that actually having the smart technology might give. Does that tie in with your analysis?
No, okay. Thanks for your question. For us, exactly, people is just in the extreme of the circle because of the planification. Sometimes the government is just inside, and all the actions inside the government don't think about exactly the people. The people is incorporated before, after the process, because sometimes you apply some actions with like open government. And with the open government, you have the transparency, and you have the collaboration, and you have the participation. But maybe it's too late for the people to say, this is the city that I want. So for us, it's really important that the circle or the framework is like a flux from the inside to outside and return. And especially for the strategic planification of cities. All the smart city projects are really interesting for people. Are interesting maybe for or have a political vision, you know. It's like to have it's crazy, but it's like to have 2,000 cars in the city, and you have a political representation that say, okay, I am ready to put a new parking for 200 cars and an APP to solve the problem in the city. I am smart because I have the parking and I have the APP. It's crazy. It's crazy because it's not enough, you know? I really believe in your idea.
Any more questions? Gunstram, I see you. No? Okay. Miguel.
Thank you, George, and to the exponent. Thank you to everyone to resist a hard day, and expect tomorrow you see at 9:30 to continue with the second exam. Thank you, George.